Okay, hi, see you again. My name is Satrio Wicaksono, and I'm here to teach you about the introduction to engineering design. Okay, our topic today is materials and manufacturing. The expected outcomes of this week is like this. You can read it by yourself. Everything will be taught today in this video. Okay, but you have to know something. Actually, this video is just like introduction before you go inside of the real class. So later, try to watch the video and see which part you don't understand and which part you understand, and later we can get better discussion inside of the class. Okay, now about materials. Okay, there are several problems about materials that we normally face in our everyday life. The first one is how to choose material, and the second one is what are the requirements of material use in components. Okay, if we made a wrong decision on this, there will be a failure. Okay, there are several type of failure that normally happen. It's because blunder in choosing material and operational blunder. Okay, before moving further, I need to tell you about brief history of material. Okay, at the beginning, the use of ceramics and polymers are very high, and after that, because of industrial revolution, the use of metals is become very high, and at this stage, okay, it's because of industrial revolution, and nowadays, because of the advancement in all materials, the usage is more or less the same in polymers, composites, ceramics, and metals as well. Okay. Okay. In order to tell you about the development of our material, you can see this example. This is the example of vacuum cleaner from year to year. At the beginning, in 1900, it's made of wood, okay, and the power is only 50 watt, but the weight is 10 kilogram. The price is very high at the time, 270, and after that, there are several development, and nowadays, you can see, the power is getting very high, 800 watt, the weight is very small, 4 kilogram, and the cost is much less as well, 60 kilogram. Everything is possible because of the development in materials. Now, I will tell you about material classification. Okay, we can classify material based on several things. The first one is based on raw materials. The second one is based on size, and the last one is based on function. Based on raw materials, we can divide it into 4: metal, ceramic, polymer, and composite. Now, I want to discuss about the first classification because of material classification based on raw material, metal. Okay, metal is the material with the most usage in industry. Okay, and the thing is, it's never been used in pure form because of low strength. Mostly, we use it in alloy form. There are several types of metal. The most common one is steel, bronze, brass, and stainless steel. Okay, stainless steel is the steel that has one additional properties: anti-corrosion. Okay, why it has its anti-corrosion? Okay, it's because of the formation of the atomic layer Cr2O3. Sorry. Okay, it's better for you to read about it by yourself. Okay, why these atomic layers will help with the anti-corrosion. Now, the second type, ceramic. Okay, there are several different ceramic, but we can divide it into two big parts. The first one is traditional ceramic. The second one is engineering ceramic. Okay, for traditional ceramic, is normally made of silica or glass or clay. But for engineering ceramics, is normally made of silicon carbide, and we normally use it in high strength ceramic application or high temperature ceramic application. Now the third one is polymer. If you studied about it in high school, polymer can be divided into two big parts. The first one is thermoplastic. Thermoplastic is polymer that can be recycled. For example, PVC, PMMA, Teflon, nylon. And the second one is thermosets. It's permanent and cannot be recycled. For example, epoxy. Now the last one. This one is the most interesting one. It's composite materials. Why is interesting? Because it's actually combination of two or more materials. Okay, normally it's in the shape of matrix for bonding and fiber for strengthening. Actually, for strengthening, it's not always in the shape of fiber. It can be particulate as well, or it can be other shape as well. Okay. The advantage of using composite is we can exploit the advantages of its component. Okay. You can see now, this is aeroplane. You can see the usage of composites from year to year is getting increased. Okay. Now the latest aeroplane tend to use around 50% of composites or more. Why? It's because of its lightweight application. It's lightweight, but the weight is very light, but the strength is very high as well. That's why the use of composites in this kind of application like aeroplane is getting more and more. Now, think about what other application that the composite usage is getting more and more. Please think about it. Okay, I give you a hint. It must be lightweight and high strength is needed as well. Think about it. Okay, we will discuss in the class. Now we will go to the second classification. It's about classification based on materials function. The first one is structural material. Okay, this is the usage in the construction or the machine components. And the second one is, this one is the most important one, biomaterials. The usage is related to human body. Okay, and what's the most important thing in biomaterial? What's this? It is biocompatibility. What is biocompatibility? What is that? Biocompatibility is actually whether a material is compatible to human flesh or not. Okay, you can search for it. What materials that have good biocompatibility and what materials that doesn't have good biocompatibility. Now, I will tell you about materials' mechanical properties. There are several. Actually, the first one is yield strength, ultimate strength, and breaking strength. Okay, beside that, we will have the modulus elasticity as well. Modulus elasticity is normally used at this area. Okay, I will explain about this material's mechanical properties in much deeper inside of the class. But before that, please try to look for it, try to search for it. Okay, what is yield strength? What is ultimate strength? What is elongation? And what is modulus elasticity? This is the comparison between material mechanical properties. You can see the comparison is in the specific strength. The left picture is about the specific strength against specific stiffness. The highest one is actually ceramics, but there is one weakness of ceramic. It's very brittle. Okay, and composite is quite high as well. That's why we use it in a lot of applications nowadays. And on the right, picture on the right is showing the strength against the cost. Why it's important? Because in our production, everything is related to cost. There is no use. You can't create a mass product. Even your product is good, but the cost is very expensive. You can't create a product like that. Okay, that's why it's better for you to study about it. Okay, in some application, you can see that composites is actually having a very high strength, but it's very expensive as well. If you need lower properties, you can use metal. Okay, and even lower, you can use wood. Now, we will move to the second part of our class today. It's about manufacturing. You already know that manufacturing is a process of converting raw materials into finished product. Okay, there are several ways, there are several manufacturing process. The first one is casting. Second one is bulk deformation, sheet metal process, machining, polymer processing, joining process. Why I skip those parts very fast? Because those parts you can study it by yourself. Okay, please study it by yourself. Later in the class, of course, I will tell you one by one in more detail. Now, this is the most important thing that I need to tell you about. It's about the more modern manufacturing. There are 4 elements in good manufacturing process. Okay, the first one is movement of materials. Second one is time, cost, and quality. If you can control those 4, your manufacturing will be very good. There are several examples. Okay, there are several examples of modern manufacturing. The first one is just-in-time manufacturing. It's minimize the inventory of raw materials, parts, and finished product. Okay. Beside that, we have flexible manufacturing system. This manufacturing system, okay, has flexibility to allow system to rapidly react to production changes. And after that, we have lean manufacturing. Okay, the main purpose is zero waiting time, zero inventory, internal customer pull instead of push, reduce batch sizes, and reduce process time. Okay, and the last one, life cycle manufacturing. Okay, because nowadays we are moving to more and more green technology. This one is related to that. It considers environmental impact of manufacturing process, so it tries to recycle product that can be recycled. Actually, that's all for today. Please remember, there are several things that I told you in this video that you need to study by yourself. Please study it by yourself before you go inside of the class. Okay, that's all. See you in the class.